Hi everyone, this is Spuggyhawk and welcome to Turtle Time. In this episode I'll show you the fundamentals of programming and we'll start writing some programs. Computercraft computers and turtles use a programming language called Lua, Portuguese for moon. I'll put a link in the description to the Lua documentation. Like most other structured computer languages, it's based on three fundamental principles: sequence, selection, and iteration. Sequence simply means that your code will be executed one instruction at a time in the order it's written. Selection means that you can perform a test and decide to do something instead of just the next instruction. Iteration is just a technical word for looping round and round the same instructions a number of times. We can try out some simple programs to demonstrate these ideas and also get used to the program editor by using the computer that's at the heart of the turtle. Right-click on the turtle to access the interface. Previously, we've just run, or executed, some built-in programs by typing their names. Create our first program file by typing edit sequence. It's still just a black background with white text, but now we're editing the content of a file instead of just issuing commands. We'll just get the computer to display 3 lines of text on the screen. Type the following: print, open bracket, inverted commas, line 1, close inverted commas, close brackets. Then the same again for line 2 and line 3. Print is a built-in function. That means it's always available to all computers whether they're in a turtle or not. Because print is a function, we can give it some information to process. This is called a parameter. It's the information that you provide inside the brackets. All the print function does is to display the text you've given it in the parameter and add a new line afterwards. Let's try that out and check it does what we expect. First, save the file by pressing Ctrl, then using the arrow key to move to save, and then pressing Enter. Then exit the editor by pressing Ctrl again, choosing Exit. Please note that the Turtle editor is very simple. It doesn't do any checking, so if you make changes and then exit without saving first, you'll lose those changes. Run or execute the program we've written by typing its name, sequence. As you can see, it has displayed or printed those 3 lines of text. Next, we'll copy the sequence program as a starting point for the selection example. CP sequence selection. If you prefer, you can use copy instead of CP. Now edit selection. Selection is about doing one thing or another depending on a condition. A condition is tested using if and then. Let's add a test to this example that will perform a test so that line 2 isn't displayed just at the moment. First, add the following line as shown. If, bracket, 1 is greater than 2, close bracket, then. Clearly 1 is not greater than 2, so that condition is false. So the following code will not be executed. But we also need to tell the computer what code we're talking about. In this case, we're only interested in the print line 2 code. So after that line, add the word end. The block of code between the then and the end is what the if will deal with. The computer will be perfectly happy with this, but for us poor humans, it's a little bit difficult to read and see what's going on. We can add a couple of spaces to indent the block of code to make that clearer. Let's save that and exit, then see what happens when we run it. As you can see, the line 2 didn't appear. We won't be using selection just yet, so we'll cover that in more detail later. Finally, let's see how iteration works. Edit iteration and type the following: for I equals 1, 3 do. print line end. There are a few ways of looping or iterating in the Lua language. In this case, we're using the for loop. This loop will execute code a specific number of times. The code it will execute is everything between the do and the end. This is called a block of code. To make things more readable, I indent blocks by 2 spaces. The computer doesn't care about the extra spaces, but it makes things a lot easier for us to read. Save this file and exit the editor, and we'll try it and see what happens. As you can see, it printed the text line 3 times. Let's make a change to the program to get a bit more out of it. The up and down arrows on your keyboard will let you go back through the history of commands you've typed, so press the up twice and that should bring the edit command back. What's actually happening here? Well, when the computer sees the for instruction, it will create a variable and store a value in it. A variable is just a named bit of memory to hold information. In this case, we've called it I. That's a common name for loop variables. It then stores 1 into the location I. As with the sequence example, it then carries on with the next instruction, the print. When it gets to the end instruction, it knows that the end is related to the for, so it goes back to the for to find out what to do next. In this case, it will add 1 to the value that we currently have in I. At the moment, this is a 1, so that now becomes 2. We're still in the range that it's checking of 1 to 3, so it carries on and does the next print. Once again, we hit the end, it goes back to the for, adds 1 to the value in I, which becomes 3. We're still in range, so once again it does the print and the end and back to the for. This time, the value in I will be increased to 4. That's out of the range we want, so instead of just executing the next line, the print, the computer will jump to the instruction that follows the end. In this case, there isn't one, so it will just finish and exit. That's a lot to take in, so let's see it in action. We'll edit the second line to include the value of I so that we can see it as it changes. The ... means add these bits of text together. The text line and a space, and the content of the variable I. The computer knows the difference because the I is not in inverted commas. Save and exit, then execute the program by typing iteration. As you can see, the value stored in the I variable shows on each line. We can use information like that in loops for all sorts of purposes. Before we can cut this tree down, we need a bit more information about how we talk to the turtle. Let's have a look at the Computercraft wiki pages. Turtles have an API, an application programming interface, that provides all the functions that we can use with a turtle. Let's find the API, have a look for turtles, and then see what functions are available. Notice that each function starts with turtle dot. So to make our turtle go forwards, we'll need to use turtle.forward. There are functions for back, up, down, turn left, and turn right. The select function lets you set which of the inventory slots in the turtle is active. If we scroll down to the yellow highlighted entries, you can see there are also functions to dig, which is directly in front of the turtle, and to dig above or below the turtle. A bit further down we find drop, which lets the turtle spit out items in the currently selected inventory slot. And the last one to mention at the moment is refuel. This is like the refuel command you use on the command line, but in this case it's for use within a program. So now we know how to make the turtle do things, let's work out what we want the turtle to do. To get to the tree, we need to move forward 3 blocks. That's a fixed number, so we can use a for loop to do that. At that point, we'll be right in front of the tree. We'll dig 1 block in front of the turtle, then move forward into the space we've created. After that, we need to harvest the trunk vertically. I think that birch trees never grow higher than 6 blocks of wood, so we can use a for loop for that too. We've already dug the first block, so now we'll dig up and then move up 5 times. It's more than we'll need for shorter trees, but we'll get something that works first and then refine it later. When we've dug all the wood from the tree, we need to return to the starting position. We moved up 5 times, so we should move down 5 times too. We could then reverse back to the chest, but instead, let's turn right twice and move forwards. When we get back to the starting position, we can drop the wood we've got into the chest. The last thing to do is to turn right twice again, so we're in exactly the same position that we started. That way, we can do all this in a loop to continually harvest the tree and store the wood in the chest. Let's write the program to do this. Edit Lumberjack. This program is going to be considerably longer than the little examples we wrote earlier. To help us keep track of where we are and what we're doing, we can add comments to the code. When the computer gets to a comment line, it just ignores it and skips to the next line. You start a comment with 2 minus signs. So here we'll have the title of the program. We can put placeholder comments in to match the blocks that we've worked out. So first, we need to move forward 3. We'll do this with the for loop that just goes from 1 to 3. The name of the variable isn't important because we're not using it to track anything. All we need is the count. Next, we need to dig forward. Then we need to move forward. Then again another loop, this time digging up and moving up 5 times. Then another loop, simply moving down 5 times. Then we need to turn around. And move forward 4 spaces. Now we need to drop the cargo that we've got in the chest. Before we write this part, let's get the turtle set up for actual use. It will need fuel, so let's put some charcoal or coal in slot 1. The slots are numbered from 1 to 16, top left to bottom right. Now that we've got slot 1 taken up with fuel, we don't want to empty that into the chest. So let's loop through each of the other slots, starting with slot 2 and finishing with slot 16. In this loop we do 2 things. We need to select the slot and then drop the content of that slot. Finally, let's turn around so we're facing in the right direction again. Save this file and exit the editor. Type refuel to ensure the turtle has at least 80 energy units available to it. That way we know it can harvest the tree and get back home without problems. Execute the Lumberjack program. Okay, we now have a program that can harvest a tree for us. There are plenty of improvements we can make, and we'll get on with those in the next episode. A very important thing to bear in mind is that if you dig up your turtle, it will delete any programs you've written on it. This seems a bit harsh, but there's a good way to deal with it. we can build a disk drive and make floppy disks to store our programs. Let's do that now, and we can copy our Lumberjack program to a disk so it won't be lost if we need to move the turtle. To build a disk drive, you'll need 7 stone and 2 redstone. 3 sugarcane will give you paper, and 1 paper and 1 redstone will give you a floppy disk. The recipe for the disk drive is very similar to the computer recipe, the main difference being in the square in the middle at the bottom, it's redstone instead of a glass pane. So with 3 sugarcane across the middle we can make paper, and with 1 piece of paper and a piece of redstone we can make a floppy disk. You can dye floppy disks with different colours. For a turtle to access the disk, you need to place the disk drive next to the turtle and place the disk in it. When you then open up the turtle's interface and list files, you'll now see the disk listed. We can copy the Lumberjack program to the disk. And if we now list what's on the disk, you'll see that that's there. If we now dig up the turtle, we're going to lose the sequence selection and iteration programs because we haven't copied those. But it's a good example. We're not losing much there. So if we place the turtle again, you can see the disk and the ROM. So all those programs are gone, but the Lumberjack program is still on the disk. We can copy it from the disk back to the turtle. The dot just means the current directory. You can see it's there, and if we edit it, you can see that's the program that we were dealing with earlier. So we can just exit that. And that's it for today, I think. Thanks for watching. See you next time.